Hi everyone. In this video we're going to look at 3 diagnostic properties that might help with identifying minerals: color, luster, and streak. As you can see here, I have your lab kits and I've taken out several minerals, and all of these minerals you could probably classify as white or clear or translucent maybe. And these minerals are a really good example of why color, luster, and even streak aren't necessarily great diagnostic properties when trying to identify minerals. So, for instance, I have the mineral quartz in front of me. I have a prismatic example of quartz, but I also have an anhedral example of quartz. And as you can see, these minerals look quite different. This prismatic sample here, I would consider this to be quite translucent. You can almost see through it. Whereas this anhedral sample is quite milky. I would still consider it translucent in a way, but you can't see through it nearly as easily as the prismatic sample. So based on the color and appearance alone, you might not be able to tell that these are even the same mineral, right? I've got another mineral sample here, halite, and if you look at this mineral sample next to the anhedral quartz, these look very similar. And even a trained geologist might not be able to tell the difference between these two minerals simply by looking at them. You would need to use something like hardness, or maybe even a special property like taste. As you know, halite is rock salt. It would taste salty, to differentiate the two. In addition to those two minerals, I have 2 other translucent minerals, gypsum and muscovite. And these 2 minerals also look incredibly similar. As you can see here, the muscovite is platy in appearance. It has a platy crystal habit, but so does this example of the gypsum. Okay, so these are both thin, platy, translucent minerals. Now, the muscovite is quite a bit thinner because it's been broken off in this very thin sheet here, and you can even bend it with your hands, whereas the gypsum is a little bit more brittle because it's a little thicker. But as you can see, they're both quite similar looking. Now, all gypsum doesn't look like this. As you can see here, I have another example of gypsum, and this gypsum has a more massive crystal habit than the platy euhedral crystal habit that this sample has. Okay, so these are the same mineral, but they look very different. They have different colors as well as different lusters. This one is translucent or vitreous, whereas this one would be more of a milky color. Moving on from gypsum, I also have a sample of calcite here. Now, calcite has a very rhombohedral crystal habit, which makes it easier to identify than some of the other minerals, but as you can see, it still has that kind of milky, translucent look to it that makes it kind of similar to these other samples that I've shown already, such as quartz, halite, gypsum, and muscovite. So my point here is that all these minerals look fairly similar. They all have that kind of translucent, vitreous luster to them, but they're all very different minerals. So color and even luster aren't necessarily great diagnostic properties. Now, I do have a streak plate here, and a streak plate can often help in determining the mineral identity, but with these minerals, oftentimes you'll get a very similar streak as well. So we have the calcite, it leaves kind of a translucent streak. Gypsum, similarly, doesn't really leave very much of a diagnostic streak on the streak plate. If I move on to quartz, well, quartz is harder than the streak plate, right? A streak plate has a hardness of around 6.5. The quartz has a hardness of 7. So there might actually be some streak plate on the quartz crystal rather than any crystal left behind on the streak plate. Muscovite and halite will also leave clear or translucent streaks, so you aren't really able to use the streak plate as a diagnostic property for these clear minerals. Now, the streak plate can be a good diagnostic tool for certain minerals. I have 2 examples of the mineral hematite. I have this red sample as well as a more metallic gray looking sample, as you can see here. Now, these are both the same mineral. They're both hematite, and as you can see, they look quite different, but they should leave a similar streak on the streak plate. So as you can see, this red hematite sample left a very red streak on the streak plate. And if I take this more metallic gray looking hematite, we should get a similar colored streak. Now, it's coming out a little gray in this example. There might be some impurities in here that are causing that to happen, but it's more red than you might expect, and certainly more red than you would get from something like pyrite, which is going to leave almost a black streak behind, okay? So streak is a good diagnostic property for some minerals, as long as they're not translucent and white, as you can't really see it unless you had a black streak plate, which I don't have in front of me. Now, some other minerals, like obsidian that has this glassy luster to it, won't leave a streak as well. As you can see here, there's no real streak being left behind on the streak plate, and this is because it would leave a clear or translucent streak behind, which you can't see. The mineral magnetite, which has a very dark gray color and metallic luster, will also leave a dark gray streak on the streak plate, similar to pyrite. Now, other minerals like olivine, which has a very earthy luster, won't leave a streak behind, right? This is a green mineral. You might think it would leave a green streak, but because olivine has a hardness of 6.75 and the streak plate only has a hardness of 6.5, the olivine won't leave anything behind. So similar to what we saw for quartz, the streak plate isn't really a good diagnostic property if the mineral is harder than the plate itself. So in this video, we looked at several different mineral samples from your lab kits. We looked at quartz, both anhedral and euhedral versions of it. We also looked at anhedral and euhedral versions of the mineral gypsum, which appeared quite different. They had different lusters, they had different colors, but they would leave the same streak behind. If you could see it, it would be a translucent clear streak because we know gypsum is a very weak mineral. We also looked at the mineral calcite, which has a rhombohedric habit, as we can see here, as well as muscovite, which has a platy habit, as well as the mineral halite, which has a cubic crystal habit. All three of these minerals, as well as quartz and anhedral calcite, would have a vitreous luster to them, whereas obsidian, although it's clear and translucent at some parts, would have a glassy luster to it because it's not quite the same as those other types of minerals. As we can remember, obsidian isn't actually a mineral, it's more of a rock because it doesn't have that defined crystalline structure. We also saw several examples of metallic minerals, including pyrite, as well as magnetite and hematite. And as you can see, all three of those minerals have a very metallic luster to them. So that's it for this video. Hopefully it will help you with your lab assignments, as well as your understanding of how we use these diagnostic properties to identify minerals.